Our second video, we are going to look at solving an inequality with let statements. So here is our first sort of example. Normally I do an example on modeling just a normal equation. However, I like this particular set of notes in that there's equations and inequalities, and getting inequalities down is just as important when it comes to this stuff. I'd actually say inequalities are more likely possibilities because these are situations that I actually kind of get myself into. Maybe not this one, but I do remember during Christmas I had $20 in my pocket and I needed to get stocking stuffers and I couldn't go over a certain amount and I needed to make sure my husband, my kids all had the same amount of stuff in their stockings and blah, blah, blah. So it was very much sort of an inequality situation, except I had more variables than just two of them. So here we go. Jonah is going to a store to buy candles. Small candles cost $3.50 and large candles cost $5. He needs to buy at least 20 candles and he cannot spend more than $80. Interesting. Okay, so a few things indicate to me that this is an inequality. This at least statement is what really screams it. So this is an inequality because we have at least there, and that's really important. And now we need to figure out our let statements. So we're going to say let x be our two variables, which in this case, small candles versus large candles, be small candles and let y be large candles. Then from there we can create our two inequalities. Our first one, I like to do it right off the bat. He needs to buy at least 20 candles. That means small plus large equals 20 or less or at least. So we'd say x plus y, small candles plus large candles, need to be at least 20. So that means these values need to be 20 or more. So that's why I have the greater than and or equal to symbol. So we need 20 of them or more. Our second inequality that we're going to write is going to deal with money because he cannot spend more than $80. So we're going to be looking at these ones. We're going to say our small candles cost $3.50. Our large candles cost $5. So $3.50 times the number of small candles, $5 times the number of large candles, cannot be more than $80. So all of this has to be less than or equal to 80. All right, so when it actually comes to solving inequalities, our gut instinct is to do exactly like we've done with all of our modeling of equations and like substituting and doing all that jazz. However, we're looking at a range of values. There could potentially be multiple values, and so because of that, really the only way that we're going to really truly accurately solve this is if we created a graph. And in our graph, we're going to essentially, I'm going to say this is going to go out 15. We'll say this goes out to 20, 10, 15, 5. We're going to do the same thing here, 5, 10, 15, and 20. We're going to create a graph of this. If I look at this first inequality, x plus y is greater than or equal to 20. If I were to write that in slope-intercept form, that would look like y is greater than or equal to x minus 20. Or, whoa, goodness sakes, sorry. 20 minus x, flipping stuff around in a way that is not accurate. And so then I will create my y-intercept at 20, and it goes down, rise over run, 1 over 1. So I'm going to flip this over to the side because we have a solid line here because we have the equal to. I can just draw this line here. And I have y is greater than or equal to these numbers, so I'm looking at all of these values above this line, okay, for my shading. Now let's look at this next one. I need to turn this into slope-intercept form as well. It's going to take a little bit more work. 5y is greater than or equal to negative 3.5x plus 80. I'm going to divide by 5 on everything. So I get y is less than or equal to negative 0.7x plus 16. And this, technically, negative 7/10. I wanted to look at that slope in terms of a fraction because we love fractions and we're good at them. They are so fantastic. So I'm going to start graphing this, and I'm going to just sort of eyeball things. It's going to be a little messy. So I'm going to go to about 16 on the y-axis. I'm going to go down 7 units over 10 units. So 16 down 7 will give me about 2 this 9, right? Yes. And then 10. So I'm going to be about there. I'm going to do the same thing down to about 2 over 10. And I'm now going to make my graph. This particular graph is not pretty. Oh my goodness, it's not pretty. That's what happens when you don't have graph paper. Either way, this says y is less than or equal to, so I need to shade below on this one, which makes me a little nervous and asking myself, like, do we even have some overlap? Oh, yeah, we do. We do have a little bit of overlap. So essentially, Jonah's ideal candle buying excursion will happen somewhere in this realm over here, where we're buying a whole lot of small candles and not a ton of large candles, but we are still spending $80 or less. So these are the values that will work for Jonah's situation. I guess technically these are the values because I guess he can go over 20, so I'll just make this really clear. That is our solution region. Solution region. And so we could look at various points. We could say, okay, 20, 0 would work, so 20 small candles and 0 large candles. We could look at saying 20 small candles and 3 large candles maybe would work, and that sort of thing. And then we could look at various points and have them work in that inequality. Kind of neat. Either way, one more video after this, just doing one more modeling problem that's a little more in depth than just a basic monetary money-based problem, and then you'll be able to start working on your practice problems and your exit paths. Thanks for watching. Bye.